So to give you some background, CADpoint is based in Crowthorne, Berkshire, and is a gold partner for Autodesk software. We have a team of experts to assist in all aspects of design. We are also partners with some of the most trusted hardware manufacturers in the industry, including HB, NVIDIA, and 3D Connexion. Our team can also offer introductory training for new customers to advanced courses for experienced users to help you get more from your software. Moving on to our technical consultant, Jonathan Reinhardt, who will be speaking to you today. Jonathan has an immense amount of experience in the architecture industry. He has worked as an architectural technologist in SME firms and more recently as a BIM manager in a 15-person architectural practice. He has presented at many various BIM events as well. So it is now with great pleasure to pass you on to Jonathan to go through Boost Revit productivity with Dynamo workflows. Thank you.
Thank you very much, Elena, and thanks for that kind introduction. So yeah, as Elena said, thanks everybody for joining us this morning. I'm going to cover Dynamo workflows for architects and engineers, and I see quite a lot of people have not used Dynamo, so I'm going to do I'll do a bit of an introduction and give you some context on why you might use Dynamo, where it sits in the industry, but then also some practical examples as well. And if we've time at the end, I'll jump into the user interface of Dynamo and just demonstrate how you put a script or how you start visually programming. So today you'll hear me use a lot of terms. You'll hear Dynamo scripting, and this all refers and comes under either computational design or visual programming. They essentially mean the same thing. So just if you hear me saying them, they all mean Dynamo or visual programming or computational design. And I'll paint a bit more of a picture as I move through the presentation. So yeah, as Elena introduced me, background in architectural technology, designing buildings, supervising buildings and working in BIM management as well across Ireland and also doing some work in the UK and Australia as well previously. So I won't hang around too long on that. So today's agenda, I'm just going to run through, give the context of how BIM is maybe changing the building design industry, some of the new challenges that we're seeing in this, how does computational design or visual programming sit in within the design factor as well of your workflows, and what's, I suppose, the solution that Autodesk presents for computational design as well as visual programming, and how is it being used in the industry, and then I'll jump into a demonstration as well at the end. So how is BIM changing the industry? I suppose, end users and companies are experiencing a lot of change in the industry too, and much of it is driven, or at least is being facilitated by BIM. And this change is quite disruptive, as you may know, whether you're either considering move to BIM, to 3D processes. But this also brings a lot of opportunity as well as being slightly disruptive. It brings a lot of opportunity as well. It allows, for example, architects and engineers, to explore a lot more alternatives earlier on in the project, whether you're using Revit, a 3D software, but Dynamo allows you to leverage those Revit workflows even further, and it completely integrates with Revit as well. BIM is also helping the industry, I suppose, move out of the dark ages and become more efficient as well. And one of the ways this is happening is by, multiple people connecting different phases of the design together, and, the blur between those roles is becoming quite different as well. An example of this is an architect and an engineer collaborating together on maybe a conceptual design, or an engineer and a contractor working together to bring fabrication level of detail much earlier into a project than before, and Dynamo can help you with these type of workflows as well. And also simulation, we're seeing that quite more often as well, and this is being used by a lot more people. And Autodesk has invested a lot in simulation in the last few years, and what they've seen is more companies are starting to adopt all kinds of simulation, including robot, green building studio, CFD tracking as well. And this is even extended to architecture and energy analysis as well. And Dynamo can support some of the workflows within this as well. And that's just kind of painting the picture. And there's also a prefabrication focus in Dynamo as well, that you're able to pull information and to leverage your Revit and your design information as well from within your design model. So some of the challenges that we're seeing in the industry, we're seeing an increase in need to maintain early design knowledge. So being able to view a model and to being able to use that model and pull all the information that you can as much as possible at an early stage, whether it's from a design point of view or even if you're looking at a pre-construction or construction point of view, particularly for contractors as well, you're able to leverage further information using Dynamo. There's also an increase in need for more automation tools to be able to reduce rework as well. And there's a need to improve, I suppose, the change from concept to design stage and even further on into, say, tender and detailed design stage as well. And there's also an increasing need for easier modeling, visualization and analysis tools as well. So how does computational design factor into this, or visual programming as it's also known? You're able to apply behaviors and logic to your model, and this is done by creating rules via a visual or scripting interface, and in this case Dynamo is the scripting interface. It allows you to build a system, not just a model, so a system of rules by connecting nodes using Dynamo, and each node has a different purpose, and I'll run through some demonstration of how that would work in principle as well. And you can extend to other applications of the model as well, so it's not just Revit. You can also use this on Civil 3D. That was released in the last number of weeks, so we're looking at that as well, being able to automate some of your Civil 3D workflows for civil engineering and infrastructure projects. So many companies are looking at computational design as a means to solve a lot of these type of challenges, so that it allows users to make high performance and, I suppose, economical structures as well without having to learn programming, and allows the designers to focus on ideas and less documents fall out of the process without having to rebuild models. So you're working from the single source of truth, or the single model as well. And its tight integration of Dynamo with BIM creates, I suppose, a fluid relationship between building concept, design development, construction documentation, then onto fabrication, and leveraging that information for operation as well. And then users are free to iterate on design ideas and reimagine, different stages of a building's design as well. And I can appreciate what we see here. We have some sort of lattice structure. This is just for demonstration purposes, but Dynamo isn't only for geometry. You can use it within Revit to automate certain tasks like renumbering items automatically within your Revit model, being able to create sheets, output data to Excel. So it's not just looking at that kind of conceptual, what might be, a rare type of design or form of a building. It also does quite practical stuff as well. So it is all ranging. So just to keep that in mind as well. So how does computational design address these factors that we've discussed? So it does help reduce the struggle at the early design phase. It also eases the ability to design complex geometry, and it improves the designer's overall capabilities. And there we have some figures from the Journal of IT and Construction as well. And 65% have overcome design and modeling challenges, and a high 80% it enhances designers' capabilities. And I can definitely vouch for this. I've used it myself in practice. And it is a fantastic tool, I have to say. And when we speak about Dynamo, there are essentially two different versions of Dynamo. We've got Dynamo on the left-hand side, which is open source. It's integrated with Revit since Revit 2020. It comes installed in your toolbar under your Manage tab. It's being moved from Add-ins tab, and it's free to use. So it's completely open source community. Autodesk have just endorsed the use of it in their software because it is such beneficial, and it has so many features. It's integrated in there, and it's completely free for you to use. There is a standalone version of Dynamo Studio, which is a separate piece of software, and this comes as part of the AEC Collection, and it is a separate piece of software, but it's part of the AEC Collection purchase as well. And the reason you might use Dynamo Studio over Dynamo, if you have somebody in your office that is only working on creating Dynamo scripts, they'll use Dynamo Studio. If somebody is using both Revit and using both Dynamo, then they'll use the plugin within the Revit toolbar as well. So just to understand that. And anything I demonstrate today is available in both Dynamo and both Dynamo Studio. It's just a difference of one is a standalone package and the other isn't. All the scripts are still the same. All the nodes are still the same. So just in case there's any sort of confusion there. So why would you use Dynamo? So you can do more with the info in your BIM model, so being able to leverage floor area information, create custom functions such as automatically create your sheets, automatically create levels, and I've got some examples that I'll open up the scripts and run through the principles within those as well, and I'll show you how they work. And if you even take a screenshot of what I show you, you're able to replicate those in your own Dynamo package if you're currently using Revit as well. And it also allows you to analyze data in a different way, as well as create conceptual modeling as well. So it's not only conceptual modeling. And in my experience, analyzing the data is probably one of the most beneficial things you can do, even if it's pulling floor areas and linking it up with specification information, or linking it up with a bill of materials from a quantity surveyor in an Excel spreadsheet. You can do all that using Dynamo as well. So it's extremely malleable to your work processes, whether you're working on one-off buildings, whether you're doing home extensions, or whether you're doing multi-story high-rise buildings or hotels. There is a opportunity for Dynamo in your workflows. So visual programming, it's not, you don't need to know code. Code sits in behind the visual programming, and you might recognize this. I know this is an iPad app that kids use. It came out of MIT in the US, and this is called Scratch, and this is essentially a type of visual programming as well, in that you have a series of nodes. Each node does something else, and as you connect the nodes, they perform a function. Now, behind those functions, the code is built behind it. If you know code, you can go in and edit that code if you want, but you don't need to know the code. All you need to do is understand the actual nodes that sit at the front end of it, and I'll run through that in my demonstration as well. So this is the user interface of Dynamo. You've got individual features, and these are your nodes. So as you can see, the small grey boxes here on the right-hand side, each one of those is a node, and it has the dark heading with the white text. As you connect nodes, they perform different functions. In this case, we're just adding some points, which is fairly basic stuff, but I'll show you how you might use points to maybe create geometry as well, and lay out, maybe a row of houses or a row of beams as well, or even leveraging further for data as well. So the user interface it's relatively intuitive. You've got a library on the left-hand side. You've got your nodes here on the right-hand side. And when you open this from within Revit, it automatically connects into the project that you have open in Revit. It knows that it's connected to that project, and it will look for the information in that project automatically as well. So it's automatically connected and integrated as well. So why might you consider? It allows you to quickly explore parametric design concepts. And as I said, it's not only geometry, conceptual designs, it's also analyzing data as well. And that works across, obviously, Dynamo Studio and Dynamo. It allows you to rapidly iterate your design as well. Here we have a facade, for example. You're able to change the shape of that facade by using something called number sliders. Just by giving it different parameters, and you're able to manipulate the appearance and maybe the layout of that facade as well. And that's probably looking at the more conceptual end of things as well. But just to understand, how far you can really take Dynamo as well. You can easily analyze and visualize your geometry as well. Here we have a roof design, and we've linked that to a solar analysis back in Excel, and you can see the color coding on the panels in relation to the solar gains and the solar heat on the roof as well. And you can see it here sitting back in Dynamo. So again, probably at the more conceptual design stage or conceptual use case, but just again to see how far you can actually push it as well. You can effectively work with other teams that use other tools as well, and as I mentioned, you can use Civil 3D You can import different 3D files, whether it's CAD, whether it's an FBX file or an SAT file. You're able to import that into Revit and work with that geometry by using Dynamo as well. So just to see how you might be able to design parametric as well. So how is the current Dynamo currently being used? So at the concept stage, you might have architects and engineers, creating stadium layouts, daylighting analysis, programming analysis, then looking and moving through to maybe the more practical design stage, sheet manage, being able to create sheets automatically within a Revit file, saving you having to create, tens or 20s or hundreds of sheets for a particular drawing. You can program Dynamo, for example, to create a sheet for every single view that you've created within your Revit project. It will actually place that view on the sheet itself. You might just have to go back and tidy it up and maybe, center it or change your viewport, but you can see how it allows you to manage that content and automate those type of workflows as well. Then at detailing stage, for engineers and detailers and subcontractors as well, for example, using curtain wall fabrication tools, being able to pull your information out of Dynamo and being able to manipulate it to create fabrication drawings and detailed drawings as well. And then looking at the pre-construction stage, how you can use it to schedule information, estimate information, even manage some concrete pours as well. And then on site, being able to use it to perform QA and QC tasks as well, and feeding that information back into your model. And then operation stage, being able to hand over maybe like an Excel data sheet of if it's Kobe information, if it's FM information, if it's your operational information. You can pull all that out of your model and push that into Excel or whatever preferred format and hand that over to your operations team as well. So what does this mean for you? So I suppose looking at an architectural point of view, it allows you to design better buildings, design more design options, and communicate better with clients by being able to present these options to them as well, and understand maybe energy design based on rules. Allows you to design more freely and enabling you to extend the power of Revit as well. And I will also mention just Project Refinery, just to be aware of that. It's something that Autodesk have focused on the last few months as well. And there seems to be a lot of energy behind that as well in terms of optioneering. I won't go into it too much today, but that's kind of definitely the next step in Dynamo, is that you're automating the layouts of maybe apartments or building designs on a particular site, given a number of parameters as well. From an engineering point of view, it allows you to become better problem solvers, so study more design options, rationalize your systems as well. You can even access the APIs if you have the programming skills in-house, or create a visual spreadsheet, for example, design that is intuitive to engineers, and then manage the risk and creativity by exposing any of the trade-offs as well. And then from construction's perspective, building better buildings, allowing you to understand your building in a different manner, being able to even, the architect and engineer taking data from Dynamo, from your Revit model into Excel and maybe presenting it to a contractor, or being able to hand it over to a contractor. If it's quantities, if it's specification information, if it's room data information, if it's geometric information as well, you can hand all that over. So just to show you an example of a script here we have a script. This particular one calculates an orientation of window frames. I won't go too much into that, but just to show you, this is a script. You've got your certain nodes. For example, you've got windows here, doors. All of this is passing information through each of what we call wires. Here is the gray connectors, and each node has a different meaning, and I'll show you how to understand what each of those nodes does as an example. This one is just calculating the orientation of every window and door, and then it's populating the orientation into a comments parameter within Revit based on your north, south, east and west of this particular building as well. So just to give you an example of maybe a practical use for it there. I think we have this video here. No, that's not loading, but you can see how it directly connects from your Revit environment directly into Dynamo as well, and I'll show you that in the demonstration. Being able to renumber information as well. So this particular script, there's no door numbers applied to this building whatsoever, but you can ask Dynamo by running a script to renumber every single door sequentially from left to right. So you can see here it's going from 22 on the left, the next door is 23. 24, 25, and this can, if you can imagine, if you have hundreds of doors in a building, and if new doors or design changes, and you have to renumber every single door, you can just rerun the script, and it will renumber every door automatically, saving you or saving your technician or your designer having to go through and check every single door to make sure they're accounted for as well. And then you can output that data into Excel as well. In this case, we've pulled out schedule information for wall areas, and we've pushed it into Excel. And this could be an Excel sheet that you send on to a quantity surveyor, send on to the contractor for pricing even, regardless of your project size as well. And one of the examples I'll run through is kind of looking at moving from Revit to Excel. And Revit to Excel is probably one of the most basic things you can do in Dynamo, but it's probably one of the most effective as well, and very easy to use. And I'll show you that in parts of demonstration as well. Here we have an example of placing lights according to the shape of the room. So on the left-hand side here, you can see we're inside the Revit user interface. We've got our 3D model. You can see, and then there's a number of lights placed across the top of the ceiling there. You can see, and we've got our floor plates offset in as well. So on the right-hand side here, you can see Dynamo on the right-hand side. This is within our Dynamo interface. You can see a series of blue lines. So this is essentially just Dynamo fetching all of this information that we need in order to place these particular lights. So this particular script uses something called Lunchbox, which is a third-party plugin. There are tons and tons, if not hundreds, of third-party plugins that you can use for Dynamo. And you can use them to leverage information. It's not just out-of-the-box nodes you have to use. So there are about 500 out-of-the-box nodes come installed with Revit, and there are literally hundreds of more that you can leverage from other people as well, and quite a lot of information and blogs, and the Dynamo community is extremely active and very helpful as well if you ever run into issues, or if you're thinking of something you want to do in Dynamo. And essentially what this script is doing, it's finding the boundary of the floor, it's offsetting it in by a meter, it's then coming up by whatever your ceiling height is, if it's 2.5 or 3 meters, and then it's offsetting in again by a certain distance, probably a meter, and then it's placing a point along each of those lines. It's divided each line, come along each line into the center, it's placed 4 along these. And each of those lines, then when you hit run on that script, you can choose what family to place at those points. So in this case, they've used a light family. You could do this for furniture, for laying out furniture in a room. Obviously, it's not going to go on the ceiling. You just don't give it a ceiling offset. You just give it a floor offset. Place furniture and place even parking bays in a site layout as well. So just to think of the flexibility of it as well, and it's not strictly only the examples you might see on the screen that you can apply it to as well. Here's another example, being able to change the door width if a space is accessible to wheelchair users. So on the left-hand side, we can see we have a room tag placed, and in that room tag, we've got a custom parameter down the bottom called wheelchair access. Now, if that wheelchair access tag is selected, when we hit run on our Dynamo script in the middle here, it's going to run the script wherever it finds that parameter enabled in the Revit model. It's then going to change every single door where it finds that parameter and change it to a wheelchair accessible door. So this is a 1200 door, and you will have told it, the script, which door is the wheelchair accessible door. In this case, it's a 1200 mil door, and we can see here, it's probably a bit blurry, we can see the family type. This is where we choose what door we want it to check against. So in this case, it's checking the 910 door, which is this particular one, and it's going to check if it's placed in the wheelchair accessible room. When you hit run on that script, it will replace every door. So if that's 100 doors in your building, if it's 10 doors in your building, you can imagine the amount of time that it would save you in running that script as well. So we'll just play a little video here. So you can see here, we're just going to zoom in on our room, going to select the room tag, and then just scroll down to that custom parameter under data, hit wheelchair access, hit apply. Then we're going to go into our Dynamo interface on the right-hand side here. And we've got a number of nodes connected. We're just going to hit run on that. You can see what it does here. It's pulling in every single door from that particular project that you have open. You can see the green IDs in there. They're not very relevant now, but they're your Revit IDs that it's pulling in, so you know that's every single door. It's then checking all of those doors against the wheelchair accessible parameter we have there. You hit run, and it's going to update. We've just run into, so it's just going to run it again. So it's just, you can see we've laid out this particular script just to show you the purpose and how the method of connecting nodes as well. But you only have to create this script once. So what you see here on the screen is all the nodes being connected. But obviously you create this script once, you can rerun it on any project you want. So you're only creating it once, and you can see on the left hand side the door is updated for anywhere it finds wheelchair accessible doors. So I'll run through kind of principles of maybe creating something like that as well. Some other examples. In this case, we've created a daylight analysis within an office building. So within an office building and certain design standards, you have to be able to view a certain percentage of daylight or windows looking out from your desk view. And this can be, this can be a regulation or it can be a client defined standards as well. So in this point, you can see we've got a series of blue lines, we've got a series of green lines. And again, this was built using a Dynamo script in the background. This is a 3D view from within Revit. And this is taken from the height a person is sitting in their chair from their eye level. And you can change that height to be whatever you want. So starting from a given point, it will calculate how much visibility we can see from our particular chair or where we're sitting. And you can see every green line that is shooting out. As soon as a line hits an obstacle, it will automatically turn blue. So if I place this as a blank panel with no glazing, all of these lines are going to turn blue. If I turn, if I move this post, this line is going to turn green. And you might ask, well, what can you do with all of these lines? You can then convert these lines into a ratio or a percentage of daylight viewing points that at each individual chair or each individual person sitting at a desk is able to view daylight from their particular rooms as well. So here we have a simple video again. We just select the people within our Revit environment. We've got a cut section here. We've got our 3D view, and we're just going to open up Dynamo as well. And this is a pre-made script again. You can see it looks quite complex, and it is to create in the first instance. But again, once you create it, you can reuse it on any of your projects whatsoever. And I'll show you something called Dynamo Player, which is very handy for reusing scripts at different stages of your design as well. So again, we're just going to use something called a select node, and that's just going to allow us to select the person or select the chair within our particular model. And there's a number of packages used in this as well, but just to show you the limits that you can push this to, and for the practical uses of it as well. You can imagine applying this to different use cases as well. You can change what the ratio or percentage standard needs to be for a particular building room or a particular building use as well. If it's residential, if it's apartments, or if it's commercial use, office use as well, you may have different standards. Or if you've got an existing building, so you can see from that point, they can't see very much daylight, but Dynamo has calculated it for them in its entirety as well for that particular room. And here we can calculate the percentage of view from each room. So that person can, from the room ratio, can view 10.4% of windows from where they're sitting in that particular space as well. So just to give you another use of that. So also calculating free heights from any steps to objects on the left-hand side. You can see any green line, once it hits a certain head height, whether it's 2.1 meters, 2.4 meters, whatever your standard is, when it hits something, it will turn red. You can see then in your Revit model, all the lines are recreated here as well. It's hit a suspended ceiling, obviously at a restricted height level. You need to pare back then your ceiling. So it's allowing you to run those kind of tests and those kind of analysis before you get to site, before that ceiling is built. And you don't need to draw a section, you know, draw the section in CAD and extrude all your lines. You just run it in Dynamo, give it the stairs object, give it all the ceilings and any obstruction objects above it, and it will calculate what's in compliance and what is not compliant. Here's another one from calculating an evacuation distance. Using Dynamo to create the path on the left-hand side here. It's found the travel path from door to door. So this particular door is marked with a parameter as your fire escape exit. And then worst case scenario, you just mark from this particular point, or you choose a point on the map, and it will automatically calculate the path. So if they run to that door, if that's blocked, then the alternative one to run to or escape to is your far one. And as it reaches, obviously the 50 meter is the travel distance here for this particular building use case, it will highlight and it get closer to red in a gradient map, again demonstrating sort of fire escape restrictions or issues that you might have in the building as well. And looking at the more conceptual stage, this has taken a solar analysis. It's created it into you can see a matrix image here, and that matrix image is then being placed onto a surface of a Revit object, and based on running a Dynamo script, it will calculate the most optimum use of glazing. They're extremely conceptual looking building here, but you get the sense that you can use it for solar analysis using complex facades as well. And this is just to show you the complexity of this particular script. And how far you can actually go with it as well. And this is quite a complex script, but running scripts, you know, even a portion of this size is quite simple to do and very easy to set up as well. And you can see within Revit, we've got a rendered image of that particular one as well. Looking from a structural point of view, and I'll run through some examples of this, being able to just select all of your structure and say, okay, I want to place a foundation on each end point of the end of those beams, or even if I want to create this structure, curved structure, it changes. Obviously, your foundations are at different widths. You want your structure to be some sort of consistent implementation. So when you hit the script, it will find the center point of each of these foundation pads, and it will run this lattice structure all the way up, and it will change the width of it and maintain the height of it that obviously you want to maintain, and then you can create a surface over that as well. So looking from an engineering point of view. And then also from being able to create, automatically create engineering elements based on a layout within a building as well. So here we have a video. We're just going to use a select node to select certain elements of our building, select different edges. And in the demonstration, I'll run through some examples of this. And using this select node, you can select direct walls or doors or any type of element within it as well. And when we run this script, it pulls in these different points, and we can create different structures as we move along this as well. And I'll run through some of that in the demonstration as well. And then looking for even from a mechanical point of view, in this case we're just using a clash detection script, and we want to place sorry, I'll just turn my volume off on that. We're just going to place a object every time we find a clash at that particular node. So I'll show you now. 2 moments, sorry about that. So we're just going to run a script here, taking the pipes, clashing them against the wall. We're then going to place an object every time it finds a clash between a wall and a pipe. And then from that wall and pipe clash, we're able to create a schedule of every single clash item within that as well. So I understand obviously you can do clash detection in Navisworks, but this just leverages even further, and you can push those clashes using Dynamo into something like Navisworks as well. So we're just going to run a clash detection from our walls and our pipes or our ducts within our Navisworks environment. And then just using Dynamo, we're going to pull those clashes in. So we'll just call this live design check clash. Hit run. It takes a few seconds to load in the models. It's pulling in all of those clashes. You can see from the Navisworks model, it's placed these arrow objects And those arrow objects are just, generic models that we can then schedule out as a clash item as well. Again, allowing you to clash your model in a different manner as well. Some examples of projects I've worked on myself. I've done some case studies using Dynamo, for example, for calculating floor areas. And this was just using extracting Excel floor area information for a housing layout of 178 houses in a residential site. So these are all individual houses or semi-detached houses as well. And we were able to pull up the floor area information for every single house in that project and populate that into an Excel spreadsheet. And this saved 60–70% reduction in time compared to a CAD process. And we compared it by taking, for example, in a manual process, an individual person, a technician or architect or designer, would have to polyline every single room, every single house, and calculate all of that information, and then populate that into an Excel sheet. And we summarised that this saved about 60 or 70% reduction in time. And how we did this, we used room area tags within Revit, ran a Dynamo script and pushed all of that information into Excel, and then had this information automatically colour if it was in compliance with the local floor area standards for the particular planning authority or planning department in that area as well, for 178 houses. So just to show you some examples of that. And then we were able to push that information further into something like Power BI as well, and to be able to present that information to a client as well, the floor area information, the different ratios that could be used across the site, even for private open space, public open space, and being able to calculate all that information leveraged from your Revit model using room tags, space tags, and then pushed into Excel and brought together into Excel as well. So I'm just going to jump into a bit of a demonstration here within Revit and within Dynamo as well. So just to show you maybe a more basic example of some of the stuff I've gone through, just to kind of keep it short and keep it simple for now. So you can see here within my Revit environment, I'm inside Revit. I've opened up a blank Revit project and I've created 2 walls here. So to open up Dynamo then, I just click on Dynamo. My Dynamo environment is going to open. So I'll just open it up for a second. So it's going to ask me what I want to do. I want to just create a blank node, or a blank script. So within here in my Dynamo, I've got a library on my left-hand side. I've got a series of different nodes. And if I want to know what a particular node does, for example, I can right-click on that node, double-click it, right-click on that particular node. If I just go to help, it's going to tell me what it does. It creates a string. A string is a piece of text, but you have this dictionary that's integrated into the back end of Dynamo as well, so it helps you learn as well. So this is what the Dynamo user interface looks like. So say, for example, I have created a script and I want to run it within my Revit environment. So I'm just going to open up Dynamo. So then on the bottom left-hand side here, we've got something called the Run button. If I had nodes placed here, for example, I'd hit Run and a change would happen within my Revit environment. Just before I go into the Dynamo environment, I want to show you Dynamo Player. And the reason for this is if you're in a design practice and if you create scripts, and if you might only have 1 or 2 people creating the scripts, they could be architects, they could be technicians that can do both, which is common enough. You can use Dynamo Player for non-Dynamo users to be able to use that particular script. So what I'm going to do here, I'm going to run this script and then I'm going to open it up for you. So, Control Z on that. So here we have 2 separate walls that have been drawn within Dynamo, or within Revit, correct myself there. We've got 2 separate walls here. We've got one that has a bit of a curve on it. We've got one that's fairly straight across. So I'm just going to change the profile of this wall now as well. Pull that down. I'm just going to change this to a bit of a more angled wall. There we are. Just going to finish that. So we've got 2 walls here. We can see we've got nothing between them, but you can imagine if you had something like this, how do you get maybe the beam structure from one side to the other? So what I'm going to do here, I'm just going to I'm just going to go into Dynamo Player. So this Dynamo Player is pulling in pre-made scripts. I'm just going to hit play on that. Oh, I just have to close Dynamo in the background. You can't have it open at the same time. That's fine. So I'm just going to hit play on that. So run completed with errors, and I know why this has been completed with errors. It's because I changed the shape of that. So I'm just going to go into my Dynamo Studio here, and I want to select each of my wall edges. So it's waiting. I'm going to select that edge. I'm going to select this edge. Now I'm going to hit run. It's going to ask me how many beams I want across that, what beams I want. I can have a complete drop down of everything I have installed here and at what level. So I'm just going to hit play on that again. And you can see it's placed all of those beams automatically. Now, if I stretch this wall, I'm going to stretch this wall as well. Let's just say we've scaled them up for argument's sake. I want to then run that again. You can see it's run it again. And it has kept those particular beams there, but I can undo that. I can delete those beams. So I'm going to stretch this out again. I'm just going to delete those beams for a second. I'm going to select my edges of my new walls, so just so you get a sense of how it allows you to see. I'm just going to run this. I want 8 beams. I'm going to increase it. We've got a bigger wall. I'm going to say 16 beams. And you can see it's completely created all of those beams, turned them to the direction that you want. So you can imagine that can even be between 2 flat walls if you want as well. So that's just an example of running a script in that sort of context as well. I've got a couple of other ones here as well that I'm going to run through, and then I'll open up Dynamo and I'll actually run through the scripts, and then I'll leave a few minutes at the end for a question as well. So I'm just going to delete that as well. Just pretend we're starting a fresh project here. So another example of what I've created here, I've done something called, I've created a wall sequence. And you can imagine this could be a layout of houses. I can go into Dynamo, hit play, and it creates a layout of houses. Now I can go into this particular script if I want. Okay, how many walls do I want? I might want 15, say 15 walls, and the spacing between each one. This can be the width of the house, for example. I'm going to say 7.5 meters. Hit run on that. Duplicated it, sorry, just to undo that. So if I go 15 walls, I want each one spaced by 7.5. Let's say, for argument's sake, these are just building layouts laid out in a row. And I'm going to go in and show you an example of how that has been created as well. So just before I do that, I'm also going to place room tags in this as well. I'm just going to go into my floor plan. I'm going to place some room tags in here, into my architecture tab. It's fine, we've got our room tags. Everything has a room tag placed in it now. So what I'm going to do, I want to output, say, for example, the Excel information for that. I can go into my Dynamo player, hit play. Now it may ask me for the location. It's going to ask me for what information. So I want the room information. I want the area. I want the name. And I'm going to output it to okay, I'm just going to hit run on this. It's just going to ask me for where I want my, so in here I'm just going to create an Excel file. There's a blank Excel file. It's going to link it to that, click open. So it's asking me where it wants the Excel file, the Excel information to go to. I only created this Excel file just right now on the screen. When I hit play, it's going to create and push all of that information out into Excel. Now I know this looks fairly basic in terms of it's only given me, repeated floor areas because every individual house is the same size. Each room is called something, is called the same name. But I can go back into Dynamo, for example. I'm going to go into my room tags. I can start to maybe move these different directions. Move that over there. Start to change the different. Start to change the different sizes of them. I can start to place other walls in here as well. You can imagine this is a different layout. Place a room tag in that again. And I might want to maybe select this room, call this something else. I might want to call this Office 1. Apply on that. Our name updates, and the same on this. I might want to call this one, for example, Office 2. Now, this is just showing you Revit to Excel in a very simple form, but you can imagine how you can pull any sort of parametric information that you want from this. So I'm going to open Dynamo Player again. It's going to rewrite all of that information. In fact, I can tell it to write to sheet 2. If I put in sheet 2, it should create the new sheet. So I'm just going to hit play on that. You can see sheet 1 is still existing there from the previous one, but sheet 2, which created all of those new names that I inputted as soon as I hit run, it automatically updated the new floor areas as I moved the walls as well. And you can manipulate this information. I can start to add in any sort of parametric information. So if I just minimize that, in Dynamo Player here, so it's looking for the area within rooms. So simply put, if I highlight this, it's looking for rooms. So we have rooms here. Under area, then it's looking for the area. So in this case, it's 52.3, and that is the information that it's pulling. And it's also looking for the name. So I can target any other information in here. I can target the perimeter. I can target, comments, occupancy as well, and I can also write data into the comments into any of these parameters as well. So I'm just going to open up this particular script. So I'm just going to go edit in Dynamo, and I'm going to show you what this looks like in the back end as well. And I'll show you how I create it. So I'm just going to close Dynamo Player. So in the back end of this, I've got something called the categories tag. And the categories tag pulls in any type of category from within your open Revit project. So I've got sections, Revit links. It will pull in any of that information. I've got spaces, and it does something called all elements of category. I'm just going to hit run on this, and this script is going to run the same way it ran within the Dynamo Player as well, and it's going to pull in the same information. So when I hit run, it's looking for categories, it's looking for all elements of that category. So in this case, it's found 15 rooms, and I've asked it in this particular node, get the parameter value by name of area. It's pulled in the area, so in this case, we've got a list of information. And the principle I'm trying to show here is that Dynamo breaks Revit data down into lists of information. So if you can imagine, this is area information taken from the room tag. You can be pulling in room data information from an Excel sheet and linking this up together as well. And another list of information, we've pulled in all of the names. It's pulled that in as a separate piece of information as well. And then I've brought that information together in something called a list create node. And there are about 500 nodes in here, but some of the most used ones are element get parameter value by name. And that does exactly what it says in the box. And you'll use this one quite commonly. What this does, it pulls in a piece of information from a parameter that you target. So if I target a parameter in here, it's going to pull that information into this list of information, and I can choose what to do with this particular piece of information. In this case, I've used categories, all elements of categories. I can delete, just not to confuse these things. I'll delete that one. And it's gotten the parameter from the name as well. Brought in all that information. So if I look at my get parameter value by name, it's pulled in 15 floor areas, 15 room names. So in this particular list, I've asked it to pull it together, those two lists of information. So I've got 30 items, which is obviously 15 plus 15. So I can see in the first list, I've got my floor areas. In my second list, I've got my room names. And I want to pull that information into one piece of information. And I've used something called a list transpose node. Now, I won't get too far into that. It's fairly technical, but you'll understand it as you go along. It just flips the direction of the information. If I drop this down, you can see then what list transpose has done. It's paired every item from this list at the start of this list. So at index 0 in the gray box, anything at index 0 in the gray box in the below list, it's paired it together. So you can see every room has a floor area with it. If I go down to one with a name, this particular one, 100.88 square meters. Office 2 is found at index 10 here. And then I can see index 10 here, it has paired that floor area with it. So I won't go too far into it, but just to be aware of something called list manipulation. And this can go for geometry, whether you're pulling in structural information, whether you're trying to recreate Excel or parameter information. This list principle applies throughout. And that's what I'm trying to show here. It's not only pulling Excel information in, but the principle of this particular script shows you how that works in the back end. So I'm just going to close this script now. So that's that particular script for Excel. I'm going to open up just one more as well. So I'm going to go to Manage, open up my Dynamo Player again. So in this particular one, I've got one called Create Levels. So what this create levels is going to do, I'm going to hit play on this. You can see I've got no other levels here. I'm going to hit play on this. Oh, I have to close Dynamo. Again, close Dynamo, open up Dynamo Player. I'm going to hit play on this. Takes a second. It should find, oh, it's looking for the Excel information, and I'll explain why in a moment. I'm going to hit play on that, create levels from Excel. It's placed every single level that I have in a particular sheet. So where is it pulling this information from? So first, I'm going to open up the node in Dynamo, and I'll show you now. So what it's actually doing, the questions coming in there. So I'll finish up in about 2 minutes, and then we'll leave questions at time for questions at the end. It's pulling in information from an Excel sheet, and this particular Excel sheet that I have, where am I here? This particular Excel sheet is placed in my, I've got it in here, data set. It's an Excel sheet, and what this Excel sheet has, I'll show you now. This Excel sheet has previously I've populated in all the level names that I want. I've populated in the heights that I want those to go at. So for example, if I move roof up to 80, I'm going to then create this, place this one down here. I want to call this level 6. I want to place this at, say, 50 meters. It's going to hit save on that. Oh, it's asking me to do a save copy. Exactly, I'll save that. Now I'm going to close that. I'm going to go into my Dynamo script. I'm going to direct then to the copied one that I just created, which is this one. I'm just going to pop that down. It's going to undo the previous level creation. So you can see I've added an additional level in that particular one. I'm then going to I'll run it from directly within Dynamo. Hit run. And you can see it's created all of the levels, including the one that I just added in the Excel file as well. So just to be aware, that's another way of manipulating data to be able to create all of your particular different sheets. And then finally, I'll just jump in very briefly into a geometric one as well. So just be aware you can import data from Excel and use something called a level by elevation and name, and it will create those particular nodes. You search for these nodes in your library on the left-hand side by these names at the top here as well. So if you take a screenshot of this in the recording, feel free to duplicate it for your own use as well. So I'm just going to close that one quickly, and then 1 second, we've got it open. I'm going to open up another point. Data sets, content, geometry point. And this is the one that was used to create the beams that we saw in the first instance. And you can see all these particular nodes sit in the back, and it uses something called structural framing beam by curve. So it finds a list of points. They're the points that we gave us where they're selecting the edges of the walls, and we said, okay, create a number of points, 8 points along each of those walls, and place a beam along it as well, and we told it what beam to create. Okay, I'm going to leave it there for now, and we've got a quick 5 minutes at the end for questions. If we don't get to all your questions, we'll certainly contact you afterwards anyway for follow-up as well. Okay, thank you.
Thank you, Jonathan. Yes, so as Jonathan mentioned, if anybody's got any questions, if you can place them through the Q&A session, and I think we've got 2 that's come up anyway. Jonathan, have you got those?
I do indeed. So first one there, we've got how easy it is to set up Excel sheets with headings, logos, footers, etc., and link the info into these. It's very easy. So the way you would do that, you would create the Excel sheet in the first instance as your template. Put in all of your logos first, any of the static information that is going to be in there. So your headings are probably going to be static, and you can direct where you want the Dynamo information to populate, into what cell, into what columns as well. And yes, it is very easy to do. If you contact us further, we can probably send you on some further information on that. Okay, next question. Is there a node which can put a temporary text on the floor layout? For example, show room area in the center of all rooms to allow quick review without checking properties. There is a script that does that. I don't know it off the top of my head, but there is something you can do to populate even a 3D text of all of your room information into a 3D view or a 2D view as well. So answer to that is yes. Does Dynamo Player, for the next question, does Dynamo Player come with Revit or just Dynamo Studio? Dynamo Player, as far as I know, it comes installed with Dynamo inside the full version of Revit.
Okay, thank you, Jonathan. Any other questions from anybody?
If there's no more questions, I'll just quickly jump into Excel then, very quickly, just to show you that final question. Here we go. So I'm just going to show you in Excel how you might direct those particulars. So I'm going to open up this script if it allows me to. I don't open that. How you might in Excel direct certain information to go to a certain location. So quickly, I'll open up this. There we are. Okay. So Revit data from Excel. Let's close that. Revit to Excel. There we are. Very, very quickly, I'll show you. So in this Excel node, if you go into Dynamo today, type in Excel. You'll pull in this node, import Excel, and that's to export Excel. And it got a series of different options here, and I can see I've completed this one up here. So it's telling me with the sheet name, it's telling me what sheet name I want to put it into. Whatever I put in here, it will populate into that Excel sheet, and then it asks you what start row and column. So this is how you could manipulate where you place the information. So obviously, using a number node, so your first start row in Excel is a cross here. So number 1, number 2, number 3, you just direct Excel where you want it to go to. You might want your information to start down here, for example, if you've got headings and further information up here. So that would be how you'd manipulate for that particular question you asked. So thanks, Elaine. I'll hand back over to you if there's no more questions.
Okay, thanks, Jonathan. No more questions from anybody? Okay,
I don't see anything there. No.
Just to finalise, thank you everybody for attending today's webinar. If you've enjoyed this one, we do have another one on Wednesday the 15th of January at 11 o'clock to improve building design and construction coordination with Navisworks. So we will send you a link to register on that. And another future event that's happening in January, we do have a workshop at near London Bridge on Wednesday the 29th of January about moving from 2D to BIM. So all I now say to you is thank you very much for joining us, and you have the details now to contact us for any training or consultancy that you wish us to let you know about, and yeah, give us a call or visit our website there. So we wish you a very Merry Christmas and a Happy New Year, and we'll see you next year. Thank you, everybody.
Thank you, everybody.